We're here at CERN discussing health tech, but of course the raison d'etre for CERN is particle physics. But as we have seen, there are a lot of direct links between the research performed here and what happens in health research and health technology. So I would like to go a bit deeper into that and into how CERN thinks about this part of their activities. And for that, I would like to invite on stage to join me the Director of International Relations for CERN, Charlotte Warakaulle. Charlotte, thank you for being with us. How does CERN think of that health aspect of the research that happens here under our feet and on campus?
Thank you very much, Bruno. As we have already heard, obviously, what we do here at CERN is fundamental research in particle physics. We try to understand what happened in the very first fractions of a second after the Big Bang and how the universe evolved in that very, very early moment. So this is fundamental research, basic science that is not necessarily connected directly with health. But healthcare and also medical applications, as we also heard from my colleague Magdalena just before, is really a great example of how fundamental research is a driver of innovation with deep societal impact well beyond the individual field of science. Novel ideas, novel techniques, technologies that have come from the field of particle physics have played an increasingly important role in healthcare over the past 100 years. Every day we see in clinical practice how technologies from particle accelerators, detectors, and also physics computing are vital in diagnostics and in treatment, and also in medical and in biomedical research. And of course, this doesn't happen just by itself. There's an active promotion behind that to ensure that these technologies can fulfill their potential. We work with partners in order to take these technologies to a maturity level. We work often with industry in order to ensure knowledge transfer so that the transformative potential and benefits of fundamental research really can serve society in the widest possible way.
Charlotte, a lot of the work that's done here is not specifically on particle physics, but is on data. Data is actually handling data, capturing them, storing them, sharing them, analyzing them is like the principal side business of CERN. And now, that's also very, very important for health. And data keeps growing exponentially. I mean, 30 years ago, the web was invented here to manage data. Many things are happening in the meantime. Where are we now in that space, and how does it relate to the topic of today?
I think that's a very, very pertinent point. So indeed, particle physics makes very heavy use of large-scale computing. And of course, grids are ideal tools to handle the large volumes of data that come from the Large Hadron Collider, but can also be used when it comes to wide applications in the biomedical field, from screening candidates for drugs or image analysis, or even sharing and protecting health records. And this is also an area where CERN works very actively with partners in order to ensure that the expertise and the knowledge that we have can really serve as widely as possible. Just a couple of recent examples from the COVID pandemic. At the peak of the pandemic, one of the important contributions of CERN to the collective effort to combat the virus was the open access data repository Zenodo. And here the reputation of CERN for excellence, but also as a platform of neutrality, really enabled different communities to come together to share data through this platform. We also developed during the pandemic a risk management tool to model the concentration of viruses in enclosed spaces, which is of course enormously helpful for space management. So I guess that's an example of particle physics directly in your office space. And now we're working with the WHO to develop both Zenodo but also this risk management tool even further.
One last question. During the event, you're going to talk quite a bit about science collaboration at scale. And very often when we talk about that in different scientific fields, the CERN example comes into the discussion. Oh, there is a CERN model. Can that serve as a framework for potential future collaborations? Not that they're going to be hosted here, but you know, there is a model, there is an experience, a way of doing. Tell us a little bit about the CERN model and how they can inspire other collaborations in other fields.
It's true that, of course, CERN and indeed the entire field of particle physics has a long-standing tradition and experience in collaboration. And I think what we have learned over the past close to 7 decades of collaboration is that this is really driven by having a common goal, but also having shared values. Collaborations in particle physics will bring together thousands of scientists from across the world, really driven in identifying a common goal. They come together in large collaborations where the decision making is driven by consensus. Sometimes that can take time, that can be challenging, but it is something that ensures that there is sustainability in the implementation of the decisions that are taken. Management structures are often quite light, quite flexible, and that also allows for good decision making over time. But I think above and beyond that, really important are those shared values that underpin and really drive this collaboration. And for me, the most important ones are really openness, it's diversity, and it's reciprocity, because when it comes to sharing, reciprocity is very, very important. And openness is really within the DNA of CERN. It's within our convention from 1954, a very visionary document. And this is now translated into a policy of open science, promoting publishing in open access journals, open software and open hardware. And it's also this emphasis on openness that allows us to work across disciplines, working with others in a multidisciplinary fashion, and also across borders. So I think the main lesson here is really to work in a collaborative manner, in an open manner, based on reciprocity. And we hope very much that this is a model that can also inspire others to achieve their scientific ambitions through collaboration.
Thank you, Charlotte. Thank you for being with
Bruno.
us.